A muddy river in the Florida Panhandle. Black water, almost no visibility. Divers with helmet lights descend 30 feet into a limestone sinkhole called the Osceola River. At the bottom, they find a knife, not a modern one. A stone biface, its edges still sharp enough to cut hide. It's lying next to the bones of a mastodon. Radiocarbon dating puts this knife and this mastodon at roughly 14,550 years old. That makes it one of the oldest confirmed traces of a person in North America, older than the culture archaeologists used to think was first. Here's the part that doesn't fit the picture most of us grew up with. This isn't a single desperate kill. The layers of mud around the site show something stranger, evidence that people and mastodons shared this same stretch of river, on and off, for roughly 2,000 years before the mastodons finally disappeared for good. 2,000 years. That's longer than the time between the Roman Empire and today. We tend to imagine early humans arriving in a new land and quickly wiping it out the lone hunter, the doomed giant, the fast extinction. But the mud at the bottom of the Osceola River is telling a slower, stranger story of people who lived alongside these animals, hunted them, scavenged them, and coexisted with them for far longer than we assume. So if it wasn't fast, what was it? And when exactly did humans stop simply living inside the wild and start reshaping it instead? That's the question this film is going to follow. Not through legend, through the physical evidence, bones, seeds, ash, and stone left behind by the people who were there. To understand what belonging to the wild actually meant, we have to picture the world these people woke up into. Not a wilderness in the postcard sense, a working ecosystem, and they were inside it. Across Ice Age North America, the landscape was a patchwork of extremes. Grasslands rolled across the Great Plains, cut by rivers that were really the only reliable lifelines across an otherwise dry expanse. In the arid Great Basin of Oregon, marshes and shallow lakes drew in migrating waterfowl, antelope, and rabbits by the thousands. In Florida, sinkholes like the one at Page Ladson held some of the only standing water for miles, which meant animals and the people tracking them converged there again and again. There were no roads, no permanent shelters in most places. What there was water. Every major site archaeologists have found from this period sits near a spring, a river, a pond, or a sinkhole. That's not a coincidence. Water decided where life was possible, for animals and humans alike. And the animals themselves were unlike anything alive today. Columbian mammoths stood over 11 feet at the shoulder. Mastodons browsed the wetlands. Giant ground sloths, ancient camels, native horses, and enormous bison moved across landscapes shared with short-faced bears and dire wolves. This was the wild these people were born into. Not a backdrop. Not scenery. It was the entire operating system of their lives, and every choice they made about where to sleep, what to eat, and which way to walk the next morning was a negotiation with it. Which raises the obvious question, how do you actually survive inside a system like that? The most direct answer to that question came out of a cave in Oregon. At Paisley Caves, in the northern Great Basin, archaeologists found something most sites never preserve: human waste. Coprolites, fossilized feces dated to as far back as 14,300 years ago, among the oldest confirmed human remains in the Western Hemisphere. Analysis of those coprolites shows something we know for certain, not something we're guessing at. These people were eating rabbits, antelope, foraged seeds and plants, small rodents, fish, and even insects like beetles. Not a diet of constant heroic mammoth hunts. A diet of whatever the land actually offered, day to day. In one layer of the cave, researchers found something else: a thick mat of antelope hair shorn off with stone tools in what looks like a large, coordinated harvesting event. One archaeologist working the site has proposed that several family groups came together to drive herds of antelope and process their hides at scale. That's a hypothesis, not a certainty, but it points to something important. Survival here wasn't usually about one dramatic kill. It was about small, repeated, cooperative work, tuned to whatever resource was seasonally available. That pattern holds up everywhere researchers have looked closely. Seasonal fish runs, nut harvests in the fall, shellfish along the coasts, deer, and small game year-round. The wild didn't offer one steady meal, it offered a rotating menu, And knowing the schedule was the difference between eating and not. Which brings us to the animals that everyone pictures when they think of the Ice Age, the giants. Because for those, the evidence tells a very different, much more contested story. Around 13,000 years ago, spear points start showing up in the ribs of mammoths. At the Naco site in Arizona, archaeologists found Clovis-style points lodged directly in a mammoth's neck and rib cage, physical damage consistent with a lethal attack, not scavenging after the fact. At nearby Murray Springs, the remains of a hunter's camp sit right next to both a mammoth kill and a bison kill, close enough that researchers can reconstruct what a hunting group's daily routine might have looked like: ambush animals coming down to drink at a spring, then retreat to high ground to butcher the meat. Here's the honest complication, though, and it matters, because pretending otherwise would be dishonest to the evidence. In recent years, some archaeologists have challenged the assumption that every spear point found near mammoth bones proves a hunt. A study published in 2026 argues that Clovis points could just as easily have been used as butchering knives on animals that were scavenged after they died naturally, and that the kill site label may have been applied too quickly for decades without being properly tested. Other researchers have pushed back, arguing that damage patterns on the points are consistent with impact from spear hunting, not just cutting. Scientists are still divided on this. What both sides agree on is that people were engaging directly with these animals, alive or dead, and using deep, practical knowledge of their bodies to do it. That knowledge shows up even more clearly with a smaller, faster animal, bison. In eastern Colorado, in a dry gully called Olson Chubbuck, archaeologists uncovered the remains of nearly 200 bison, stacked 3 layers deep in an arroyo. The evidence shows hunters didn't chase these animals down one by one. They read the landscape, understood how a stampeding herd moves, and drove the herd directly into a natural trap, a narrow, invisible ditch in open grassland where the animals piled up, trampled, and became impossible to escape. The bones tell us something even more precise. 16 of the animals were nearly newborn calves. That single detail lets researchers pin the kill to a specific few weeks in late spring because that's the only time of year bison calves are born. These hunters weren't guessing when to strike. They knew the herd's biology well enough to predict where it would be and when. And killing nearly 200 animals wasn't something one person could do. The layout of the bone bed carcasses trampled at the bottom, methodically butchered on top, organized into separate piles by hand shows real cooperative planning. Multiple people working in sequence, turning a single kill into food, tools, and hides for an entire group. So the wild wasn't just something these people survived inside of. In moments like this, they were actively directing it using their understanding of animal behavior as a kind of leverage. Which raises the next question. How much of that leverage came down to reading the land itself? Survival here depended on a kind of literacy most of us have lost: reading tracks, weather, water, and the rhythm of the seasons. But the clearest evidence of humans actively shaping their environment doesn't come from tracking. It comes from fire. On the northern Great Plains, researchers studying ancient drive-line hunting complexes' long funnel-shaped rock alignments built to channel bison toward a kill site found something unexpected buried in the surrounding soil: charcoal layers that line up, in both timing and location, with these hunting complexes. The pattern suggests some Native American and First Nations groups deliberately used fire to manipulate where bison herds moved, making mass harvests more predictable. This wasn't random burning. It aligned with the same climate windows that made natural fires more likely, meaning people were working with existing fire conditions, not against them. In the American Southwest, ancestors of the people of Jemez Pueblo appear to have used intensive, repeated burning around their settlements for more than 500 years. Evidence suggests it kept dangerous wildfire fuel from building up, in a way that modern fire suppression policy, ironically, does not. In the Northeast, researchers piecing together charcoal from lake sediments, fire scars on old trees, and colonial-era land records have found what many now interpret as centuries of deliberate landscape burning that shaped whole forest ecosystems. In California, historical accounts describe fire being used to make certain edible bulbs easier to find after they resprout, though there's also solid ecological evidence that some burning was kept local, near villages, rather than applied indiscriminately across entire wild landscapes. Here's the important distinction, because it's easy to blur. This isn't evidence of people dominating nature the way later agriculture would. It's evidence of people working a lever inside the ecosystem, nudging fire, timing, and herd movement in their favor, while still depending entirely on wild plants and animals to survive. They weren't standing outside the system, pulling strings. They were inside it, pulling on threads they understood intimately. Which brings us to the biggest, most unresolved mystery in this entire story, the one modern scientists still argue about today. Sometime between about 12,600 and 10,000 years ago, nearly all of North America's giant animals disappeared. Mammoths, mastodons, giant sloths, native camels, native horses, dire wolves of the animals weighing over roughly 100 pounds, most of them gone. For decades, one explanation dominated: the overkill hypothesis, first proposed in the 1960s. The idea was straightforward. These animals had never encountered a predator like humans before, didn't have the instincts to avoid us, and were hunted into extinction as human populations spread across the continent. But here's where the story gets genuinely uncertain, and it's worth sitting with that uncertainty rather than rushing past it. A major study published in Nature Communications used the largest available database of radiocarbon dates for both humans and megafauna, and found no consistent relationship between rising human populations and megafauna decline across North America. What it did find a strong link to was falling temperatures, specifically sharp climate shifts around 14,700 years ago and again around 12,900 years ago, tied to the end of the last ice age. Researchers on that side of the debate point to something simple but hard to ignore: confirmed kill sites for mammoths and mastodons across the entire continent number only in the dozens. If overhunting alone wiped out dozens of species, most scientists would expect far more physical evidence of it than we've actually found. But researchers on the other side of the debate ask a fair question back. These animals survived previous ice age cycles for hundreds of thousands of years. Why did they only go extinct during the one glacial transition when humans happened to be present? Neither side has a complete answer. Some recent research suggests the true picture may be more tangled than one cause wins, that different animals in different regions may have been pushed toward extinction by different combinations of hunting pressure, shrinking habitat, and climate stress, rather than one single continent-wide cause. And this is exactly where Paige Ladson, the mastodon by the pond, the story that opened this film, becomes so important. The evidence from that site shows people coexisting with megafauna for roughly 2,000 years before those animals vanished, not an instant collision. A long, overlapping relationship ending gradually, for reasons science still hasn't fully settled. What we can say for certain is this: something profound changed in these ecosystems at the end of the Ice Age. What we can't say for certain is exactly how much of that change humans caused, versus how much was already underway around them. That's not a failure of the evidence, it's what honest evidence actually looks like. And with the giants gone and the climate settling into something closer to the world we know today, the human relationship with the wild was about to change in a different, quieter way. Along the floodplains of the Illinois River at a site called Coster, archaeologists found something that marks a shift in how people related to the land. By around 8,400 years ago, this was no longer just a temporary camp people passed through. It was something closer to a semi-permanent village used again and again over generations, long before anyone in this region was farming. People were still living almost entirely off wild resources here: fish, deer, shellfish, nuts. But they were doing it from one place repeatedly, instead of constantly following the resources across the land. The relationship with the wild was starting to bend, not break, bend toward staying put. Then, starting somewhere between about 5,000 and 3,800 years ago, something genuinely new happened at sites across the Midwest and Southeast, places like Phillips Spring in Missouri, Napoleon Hollow in Illinois, Hayes in Tennessee, and Riverton in Illinois. People began deliberately cultivating a handful of local wild plants they had been gathering for generations: a native squash, a sunflower, a chenopod related to quinoa, and a plant called marsh elder. This wasn't the arrival of agriculture from somewhere else. Genetic and archaeological evidence shows this was one of roughly a dozen places in the entire world where people independently invented plant domestication on their own, turning wild seed-bearing plants they already depended on into crops they controlled. Scientists call it the Eastern Agricultural Complex, and it happened almost 2,000 years before corn ever reached this part of North America. This is the hinge point the whole story has been building toward. Up until now, humans had been reading the wild, following it, timing their lives around it, occasionally nudging it with fire or herd driving, but always depending on it to provide, on its own terms. Now, for the first time, people were reshaping a handful of species to meet human needs, instead of the other way around. Saving the biggest seeds, replanting them, selecting, generation after generation, for plants that served people better than their wild ancestors had. It didn't happen everywhere at once, and it didn't happen quickly. For thousands of years afterward, wild deer, wild nuts, wild fish, and wild plants still made up most of what people ate, even in places practicing this new small-scale cultivation. The wild didn't disappear from daily life. It just slowly stopped being the only option. So go back to the mastodon in the Osceola River and the people who shared that riverbank with it for 2,000 years. They weren't outsiders visiting nature. They were one more set of teeth in the food web, one more set of footprints in the mud, dependent on the same water, the same seasons, the same herds as everything else living there. What the evidence shows when you follow it honestly isn't a single dramatic moment when humans left the wild. It's a long, uneven unraveling fire here, a village there, a handful of domesticated seeds somewhere else spread out over thousands of years, across a continent, at a pace no single hunter or single harvest could have driven on its own. The wild didn't let go of ancient humans all at once. It let go slowly, place by place, plant by plant. And the evidence for exactly how it happened is still sitting in riverbeds, cave floors, and ash layers across this country, waiting to be read.